3.
Yeah.
We have to move it?
Yeah.
Yeah.
Yeah. I think that's a 3. Do you think that's a 3?
Yeah. What else would it be?
5. Oh, that's not.
Oh, I thought it was 5. No, it's a 3. That's definitely a 5. It's definitely a
No, I think it's a 3.
So it's definitely a 3. Okay, Miss Harrison should be cool.
That looks like a 5.
No, but look at the other 3.
Alright, do whatever you want to do. But I'm doing it as a 3.
5's not slanted. 5. No, the 5s aren't slanted like that.
They can.
In this font.
Okay, so if you thought it was a 5, you're going to slide a different answer. Okay. So it's not way different. dy dx is, so we take v first, isn't it? Yes. And we're multiplying that by du dx. So there's a secret 1 in front of here. Or maybe I should write it, otherwise you guys might stress. Minus u. Oh my gosh, that was loud. 6x squared plus 4 squared. Over. Oops, a daisy. X squared plus 4. So are you happy that I go straight to writing 6 here now?
Yeah.
Because we've squared it?
Yeah. It's wrong.
So I'm going to neaten up a little bit. So I've got x squared plus 4 cubed minus 6x squared. Done. Okay? Now this last little page just talks about the fact that the letters can change. dy dx, it tends to specifically talk about gradients of functions because we are used to seeing our function as y equals, and those rules tend to be in terms of x. But it can be talking about anything, and it's talking about the rate that something changes. So gradients, we know, are the rate that the horizontal changes compared to the vertical. Okay, so it's rise over the run. So that back page just talks about the fact that the letters can be different. They doesn't have to be y and x. It can be anything. I'm just chuntering to make sure you've got all this here. So it talks about rates of change. I'm going to turn back. Okay, so for example, if we had here the a equals pi r squared, we recognize that that's the area of a circle. So if we were asked to find dA dr, we would do the rule as we would have done. Okay, so the power comes in front, we take one off the power, and that's telling us that the rate at which the area changes with respect to the radius. Okay, so this is all about rates of change. Okay, specifically, most of the time we're looking at gradients, but not always. Okay? So next lesson, what we will do is we'll have we'll have a couple of questions down, so we've got 10 minutes. But next lesson specifically, we're going to just practice the product and quotient rule, and within those two rules, you're going to be using the chain rule. Okay?